All right, today we are going to unlock a feature in TypeScript that will seriously change how you write code, and for the better. We're talking about generics. If you've ever found yourself writing the same logic over and over again, just for different data types, then this one's for you. Let's dive in.
So, let's start with something every developer has felt. You know the drill. You write this awesome function, it works perfectly for numbers. Then, you need that exact same logic for strings. And then, oops, you need it again for an array of objects. You end up just copying, pasting, and tweaking the type annotations. It's repetitive, it's a drag, and it's a nightmare to maintain.
Well, there's a much, much better way, and that way is generics. Now, the main idea here is actually pretty simple, but it's a total game changer. What if you could treat a type like it was a variable, like a placeholder you can fill in later? That is exactly what generics let you do. You write the code once, and it can work with all sorts of types, all while keeping that amazing type safety we love about TypeScript.
So here's our game plan. First, we'll get a handle on this type placeholder idea. Then we'll see generics in action with functions, classes, and interfaces. After that, we'll learn how to add some rules with something called constraints. And finally, we'll wrap it all up and see why this is basically your new developer superpower.
Okay, first up, the type placeholder promise. Let's really break down this core concept with some actual code.
This right here, this is the classic hello world of generics. It's called the identity function. Now, it looks super simple, I know, but it perfectly captures the magic. All it does is take an argument and return that exact same argument. The key, though, is that it does this without knowing or caring what type that argument is ahead of time. It's all right there in the syntax.
So let's really break this syntax down. You see that T in the angle brackets? That's us declaring our type variable, our placeholder. We could call it anything we want, but T for type is just the convention everyone uses. Then, when we write arg_t, we're telling TypeScript, hey, this argument is going to be whatever type T ends up being. And finally, that .t after the parentheses, that just means the function is going to return a value of that same type. It's a perfect little self-contained contract that's completely type-safe.
So we've seen it in a really simple function. But where do we go from here? Let's move on and see how this idea can be built into much more powerful and complex things.
Because generics aren't just for functions. Check out this generic box class. Just like before, we declare our placeholder, T, right after the class name. This lets the entire class become a container for any type you want. You can see how we use T for the value property, for the constructor's argument, and as the return type for our getValue method. It's a super versatile blueprint for a type-safe box.
And using it is just as easy. Once you've defined the generic class, you just create a new instance by telling it what specific type you want inside the angle brackets. So, new box number creates a box that can only hold numbers. New box string makes one that can only hold strings. You get all the reusability you could want with perfect type safety.
Here's another example that is just so practical, you're going to find yourself using it all the time. It's a reverse function for arrays. By defining it with t and saying the parameter is an array t squared, we've just made one single function that can reverse an array of numbers, an array of strings, an array of objects, whatever. And TypeScript is smart enough to know that if you give it an array of numbers, you're going to get an array of numbers back. No more any types, just pure, clean type safety.
And this really just hits the nail on the head. This is the core benefit. It's all about making these flexible components that aren't locked into just one type. This is, honestly, the secret to writing code that's scalable and easy to maintain.
The fun doesn't stop with classes either. Interfaces can be generic too. And get this, you're not limited to just one type variable. Here, our pair interface uses TU to define a shape with two properties, first and second, and each of those can have a totally different type. You could create a pair number string, or maybe a pair of user boolean, and TypeScript will make sure the shape is always correct.
Okay, so this is all great, right? Super flexible. But what happens when your generic function needs to know a little something about the type it's working with? This brings us to our next really important topic, constraints.
Just imagine you have a generic function that's supposed to log the length of whatever you pass into it. If you pass in a string or an array, that's fine. They both have a .length property. But what happens if somebody passes in a number? Numbers don't have a length, and your code is going to crash. So how do we stop that from happening?
This is exactly where we'd hit a wall. On the left, if we try to access args.length, TypeScript immediately throws an error. It's basically saying, whoa, hold on, I can't promise you that every possible type T is going to have a length property. But look at the right. We fix it. We add a constraint using the extends keyword. We're telling TypeScript, listen, T can be any type you want, as long as it has the properties defined in this lengthwise interface. And just like that, the error vanishes. Our function is now both generic and safe.
So that's the big idea here. Constraints, which we make with the extends keyword, are how we narrow down the kinds of types a generic can accept. We're putting a requirement on it. We're making sure that whatever type gets used will have the basic properties or methods our function needs to do its job safely.
Now, constraints can get even more powerful. Let's take a look at the keyOf operator. This getProperty function is designed to safely grab a property from an object. It's generic over two types, T for the object itself and K for the key. And that constraint, K extends keyOf_T, that's where the real magic happens. This thing is a game changer for stopping a whole class of really common bugs.
So what does that really mean? It creates this incredibly powerful link between our two generic types. It tells TypeScript that the second argument, key, has to be a string that is an actual key of the first argument, object. This makes it physically impossible to have a typo or try to access a property that doesn't even exist. It catches those nasty runtime errors before you even compile your code.
All right, we've gone through the basics, we've seen them in action, and we've learned how to set rules with constraints. So let's wrap this all up by talking about why this isn't just some neat little trick. It's a genuine superpower for any TypeScript developer.
I mean, the payoff is huge. Your code instantly becomes more reusable and way easier to maintain. It stays completely type-safe, which is why we're using TypeScript in the first place, right? And this scalability, combined with all the error prevention we just saw, it just leads to building applications that are fundamentally stronger and more robust.
If you only take one thing away from this, let it be this right here. Generics lets you write one piece of logic that can work on an infinite number of types and do it safely and predictably. It is the ultimate expression of the don't repeat yourself principle.
And that's really the bottom line. This isn't just about writing clever-looking code. Mastering generics truly levels up your skills as a developer. It makes you so much better at building efficient, solid systems and just makes you a more effective programmer all around. So, the power is officially in your hands now. You can write these flexible, type-safe components that can adapt to any data you throw at them. The only question left is, what are you going to build first? Thanks for joining this explainer.